Assalamualaikum and greetings everyone. Today's topic is on common surfaces. The first surface is called paraboloid. I've shown you how to sketch paraboloid before in the previous video. If you recall, we've sketched an equation z equals x squared plus y squared equals 9. So the technique is we sketch level curves, a few. So here we have one level curve. The second is when z is -5, and here we have z equals 0. And then we also sketch traces. One is for x equals 0. That would be a view from the front. And a trace y equals 0. That would be view from the side. So when we put them together, we get this paraboloid. So this shape that looks like a bowl is called paraboloid. Okay, another common surface that we've done is a cone, where this is a general form, general equation for cone. We have z equals square root of this expression here. Here z, c, a, and b are all constant. I've shown you one example of cone in the previous video where we have this equation. Z equals 9x squared plus y squared, square of that. So the technique is still the same. We get a few level curves. So here we've plotted three level curves. Z0, z equals 2, z equals 4. So the view from above, you see, is an ellipse. And the view from the front, we get a V shape. And the view from the side, we get a V shape as well. Put them together, then we get a cone. Okay, so today I'm going to show you another common surface, which is called double cone. So I'm going to go straight to showing you an example. So for double cone, here I'm going to show you this equation, how to sketch this equation. So here you can see that the equation is not given in a general form. The general form for a function, if you recall from before, is given as this: z equals f of x, y. So in this equation, obviously, it's not given as z equals f of x, y. But the technique is still the same. You need three views. One is view from above, view from the side, and view from the front. If you still can't tell the shape of the surface, you can sketch more views from above, the front, and the side. Okay, so usually we'll pick x0, y0, and z0 as our plane. Okay, so let's look whether we can pick z0 in the equation. So if we replace z equals 0 in the equation, then the equation will be reduced to this. Okay, is that a valid equation? Yes, it is a valid equation. We can find the value of x and y so that this equation is satisfied. There's only one solution for that: x0, y0. So when z is 0, we have one level curve, which is just a point. There's only one solution to this equation. X must be 0, y must be 0. So we only have one point. So instead of curve, we have a point. So you can't tell much from a curve. So we need more view from above. All right, so a good choice would be, can we pick z equals 1? Yes, we can. All right, when z is 1, the equation will be 1 squared. So that would be 1. And on the right, we have this. Okay, and I know you're familiar with this. I'm going to put equals 1 on the right hand side. So here you can see that this is an equation of an ellipse. This is an equation of an ellipse where we can sketch this. All right, so for an ellipse, here y squared over 9, and that would be x squared over 1. So comparing number 9 and 1, obviously 9 is larger. So when 9 is larger, our ellipse would be longer, parallel to the y-axis. Okay, let's see. So here we have an ellipse. Let's see here. Oops. Oh, that's wrong. Okay, is that? Oh well. Maybe. So here we have, this is 3, -3, -1, and 1. Okay, so that is an ellipse. All right, so can Z be, another one would be, can Z be negative value? So in this case, on the right hand side we have Z squared, so that will give you a positive value. And on the right hand side we have X squared plus Y squared over 9. So the right hand side also a positive value. So in this case, Z can be negative because when you square a negative value, you get a positive value. So let's check what happened when Z is -1. Excuse me. When Z is -1, this equation will be reduced to X squared plus Y squared over 9 equals, when you square -1, you get 1. So obviously, this is also an equation of ellipse, the same equation as before when Z is 1, so we have the same size ellipse when Z equals -1. So the level curve would be the same as this one. Alright, so we have 3 views from above. Z0, we get only a point. Z1 and Z-1, we have the same size ellipse. Okay, now we need view from the front. So for the view from the front, we need to let X as a constant. So can we let X equals 0? So when X equals 0, we have a valid equation, because then we have on the right hand side, on the left we have Z squared, and on the right we have Y squared over 9, since we replace X with 0. So we can rewrite this equation as such, and we can factor the equation as Z minus Y over 3 times Z plus Y over 3. Okay, so from here we end up with 2 equations. One is Y equals Z Y over 9, and the other one is Z equals -Y over 9. So those represent 2 straight lines. Okay, so here for Z equals Y over 9, oh, that's wrong. That should be that one. We have a straight line that goes to the origin, and the slope is 1 over 9. So here we have Y equals Y over 9, and here we have Y equals -Y over 9. Okay, so we have a X shape. That would be the view from the side. Okay, now we can also get the view from the side. From the side, we let Y as a constant. I'm going to choose Y equals 0. Then the equation will be reduced to, will be reduced to Z squared equals X squared. Okay, so doing the same process as before, we can factor this equation as Z minus X, Z plus X equals 0. So again, we have 2 equations. One is Z equals X, and the other is Z equals -X. So from those 2 equations, we know that we have 2 straight lines, one with a positive slope and the other is with negative slope. Okay, so here we have, this is the x-axis, this is z-axis. Again, sorry, here should be y and here should be z. Okay, so z equals x is a straight line with the slope is 1. Okay, so we have a straight line like so. Okay, this is z equals x, and this is z equals -x. So we have an X shape as well. All right, so now we're going to put everything together in X, Y, Z space. So here we have Z-axis, X-axis, and Y-axis. This is Y, X, Z, and here we have the -Y, -X, and -Z. Okay, remember we plotted 3 level curves. One is for x0, we have a point at the origin, and we have z equals 1 and -1, and on both values of z, we have the same size ellipse. Okay, so for let's say this is z equals 1 plane, and another one we have 1 2 3 4 1 2 3 4, and this is on z equals -1. Okay, so on both well, first of all, when z is 0 we have a point. When z is 1, we get an ellipse that is longer parallel to the y-axis, this one. Okay, so let's say this is 3 and this is 3. We have to draw it here, so it goes through this point, and let's say that's a 1 and this is also a 1, so we have an ellipse here, and we have the same size of ellipse on z equals -1. So this is z equals -1, same size ellipse, so it goes through here, here, and here, and here. Okay, so we have another ellipse on z equals -1. Well, hang on, sketch it prettier, I hope. Alright, and then this is the view from the front. When x is 0, we have a X shape, and this is the view from the side. We have an X shape as well, so let's sketch that. Okay, so here we have a straight line, oops, X shape, and here we have an X shape as well. Okay, that would be the view from the front, and we also have the view from the side, which is also an X shape. Okay, we have this, and then we can't see that bit, and here we have solid line, then we can't see that bit. So here you can draw a much larger double cone. So here we have the shape that is called double cones. Okay, the technique of sketching it is still the same. But I'm going to save the other common surfaces on the next video. Thank you.